Hello guys, welcome to this video. And today we are gonna go building the loan approval system using artificial neural network behind this and we will using this numeric values like age, experience, income, and this education, mortgage, CT average, and all these parameters to predict one target variable y. Y means personal loan is approved or not, isn't it? So we will use it. Use it to do classification problems and classification problem. So here I'm importing some basic libraries in NumPys, Matplotlib, Pandas, and classification report in class confusion matrix, and I'm putting C1, and this is running it, and this is our dataset. I'm using this dataset universal bank, isn't it? I'm using this dataset, so I will give the link of this, isn't it? This is my datasets. You can see there as any ID, age, experience, income, zip code, family, education, and then there is also and there are other columns also. So there also later on by reading this, I will read the CSV file, and this is our this is our CSV file. This is our datasets as you can see from here, isn't it? Loan approval, isn't it? And then I'm gonna be describing the statistical points of the data sets. And you can see the mean average age is about 45 and 45, and mean age is 23, and mean age is 23, and with the standard deviation of 11. And you can see the education levels also. Education are given in numeric values, so 1, 2, 3 means certain level of education is an education. And this is zip code, income. I think income account, mean income of, I think you can see here the price is the mean income of this, isn't it? 70,000, I think. Of this is, and this is ours, isn't it? Data sets. And let's do some visualization, isn't it? These are ages, and let's do some visualization of our data set. This is the age distribution, isn't it? I'm just this plot is SNS or this plot is using C1 as an I'm just data sets of age, and this is our age, and we have having the more mainly from 30 to 60s, and we are having mainly majority ages from 30 to 60s, and this is the high ages. And I'm dividing educations and showing education. I think education one means certain level of education is high, is in high. First level of education is high, then second level of education is high, and then third level of education is greater than second and lesser than first, isn't it? And I am dividing the data sets into dependent and independent features. We have several columns, and we have to divide this column is dependent and which is independent. So I am just doing this in dataset.ilog. I'm just taking the rows from all the rows, and from two columns to 13th column, because 14 will be excluded, not included, is not included, no, not included, no, no, not included. And then I'm taking all the rows of the ninth column so I will show you. Then what I'm doing for this is my I am from second, is in first. This is not, isn't first, second. I'm from here to here, isn't here to here. I'm taking it, and for from 2 to, isn't from 2 to 13th, 14 will be excluded. It will not include it. Isn't what I did. This boundary value, so it is not exclude. It will be excluded, isn't it? Not included. And this is I'm taking this ninth column, so you can see here, isn't I have taken 2 to 14 and then 2 to 14s, and I'm dropping the personal loan because from 2 to 14, isn't it? You can see it, isn't it? Our dependent variables comes, personal loan also come from 2 to 14, isn't it? Personal loan also comes, so I have to drop this column, isn't from independent variables and independent variable. I'm dropping the personal loan from axis 1. Axis 1 means from columns. columns wise, and then I'm reading the heads and head of the datasets, and this is our reasoning. This is our reasoning. X, which will this is our training. It's an independent variables, independent variable, and this is my y, isn't it? Y. This is the type of loan, isn't zero or one, isn't it? Zero or one. It, I think if zero means portion doesn't a portion doesn't have. I think portion doesn't have get the loan, and one means portion get the loan, isn't it? Get the loan, and you can see here is in a wider head, and y you can see it. This is and what I'm doing here, I'm splitting the data sets into the training and testing sets. So from Ascalon.model selection, I'm importing trend test split, and I'm applying trend test split to the. I'm just giving the data points in x and y, x and y is in x and y. So with the test size of 0.2, with the size of 0.2, and random state 0 is random state 0. So this is my Mm, I'm just applying trend test split, and then I'm just saying the shape of X train is in this 40,000 rows, and 11th column is in the as is fine, isn't it? And then I'm doing feature scaling. I'm scaling the value in certain ranges, and then is using some. I'm using standard scalar, means it will use standard deviation mean, I think, to scale the values in within the ranges. So I'm applying so from feature scaling from Ascalon, after producing I'm importing standard scalar, and just I'm getting objects, and I'm just fit transforming. I'm fitting and transforming it. Extrain independent variable for training, isn't it? And for also for I'm not doing for fit underscore, just for I'm just doing for training fit transform, and I'm doing transform for tested as in. So this is our features killing part, and this is our x train is an x train is an this is our x train, and then you can see the x train like this, isn't it? We have just scaled the value within the ranges using standard deviation and mean, isn't it? This is for testing, as you can see there we have scaled the values in all the column values in seventh, one, two, three, and there are some columns, and 11th column, I think we have 11th column in x independent variables, and so this is x test, and you can see it, and this is the shape of training, isn't it? 4000 comma 11, and then you can see it, and this is our. I'm just printing the shape of extend dot shape, and you can see that this is the this is for training. I am just printing the shape is in 4000 comma 1, and this is for x train, and this is y train, isn't it? This is for y train. I have just, you can see here, this is a training shape extend dot shape, and this is y train, isn't it? What we are getting in y train, isn't it? Y train means we have getting for, isn't it? So I will show you for y train also, y test also. Y underscore test, I'll show you in what is doing here. I'll explain you every once. This is what I think you can see here. We have used some, I think it just split data set, I think, with I think. So you are not getting from one index and zero index. We are getting some random numbers from any dependent web, but it's linked with the index, so it will be easy for us for the model to find the correspondence of training of x and y for x train. Some particular index will be correspond to particular index of the training and testing. So because it's shuffled, when we are doing train test split, it's shuffled. When we are doing with random strip, we are using random strip of zeros, and so it will suffer lesson while splitting the training and testing data set. So this is our y test, and we have zero means portion does not have get loan, I think, and one means portion have get the loan. And this is our y train. As in y train, you can see the particular index zero. We have just two variables, zero or one, zero or one, and this is ours in training and y train, and then just let's do on the part of model creation. Let's do the model creation part. Listen, I will explain. Model creation part. Model creation part. Model creation part, and this is the model. I will show the model to you. And what you're doing here is, we're just we are doing we're just taking the from Keras reference product model where I'm importing a sequential model and sequential model. And what does sequential model do? I'll explain later on. Later on. So and importing layers in like dense layer, pass norm layer, and I'm just importing some layers like layers or activation function. I think like liquid relu, pre elu, elu, and relu is in it. And for us, I'm importing dropouts, isn't it? Dropouts, and what I'm doing here, I'm just creating I'm just creating a sequential, isn't it? Sequential objects like classifier objects, and I'm just creating the models, isn't it? In the first I have say 128, 128, and then I have to just remove it. No, I can't make 128 because I have to change some things, and so wait it. We are just creating a sequential objects of classifier, and I have to first, or the first input is in first classifier dot add, as in I have to add as in a dense of units 8, 8, not 8 but 11, because we have 11th independent column, isn't it? So it will be feed it, and you can see I have added it. I've added it, and just I am doing sending the input data to the in the first hidden layer, then with 128 nodes, 128, and applying mass normalization is to reduce overfitting, is and drop out for also overfitting. And this is our classification. I'm just adding some dense layers in dense layer with 64 node and with activation values in it, and adding bass norm layers in it, and dropouts of 0.2 and 0.2, and dense of 32, and I'm using activation values in it, activation value, and dropout. This is 0.3 of dropouts, and I'm adding this. This is first hidden layers, and this is second hidden layer, and this is third hidden layers in it. Just I am decreasing the nodes and decreasing the nodes while coming down, and I'm using activation function value for non-linearity to the data, to add non-linearity to the data. And this is our dropout layer, and I'm adding output layer with dense of one activation sigmoid, because I'm doing a binary classification. So I have to use sigmoid, not a softmax. So I have to give only one nodes, because this node will because the sigmoid will give those output with which with a higher percentage, that will be the it will giving in certain ranges. So which classes in among two classes, which classes have much more values will be the final results. Final results is the output layer. I'm adding output layers, and from I am just importing from TensorFlow. I am just deciding the which optimizers from TensorFlow.keras.optimize.atom with I'm specifying with learning rates in learning rate of 0.01, and I'm just compiling the model with optimizers with optimizer with this optimizers what I've defined here. And I'm using binary cross entropy for binary classification, because we have two classes. Binary means two, isn't it? 0 or 1, isn't it? You can and I'm using the matrices like accuracy matrix, and I'm doing some early stopping here. Early stopping. Mm, I'm just creating an early stopping from keras.callbacks.early stoppings with I'm validating I'm monitoring validation loss with men deltas in 0.001, and I'm using percent of 20 means I have to wait up to 20. I'm using verbose of 1 more. I think I have made autos, and so I have not restored the best words, and I am starting from epoch from 0, and I have and baseline I have given non-listening, and this is I am putting the data as an X train, Y train, and validation data as just I'm giving one X train, Y train is a Y train, and I have to give this is I doesn't give to need a validation institute, but I have a validation data as a validation data. So validation data is in validation data underscore data is in so what I have validation data is in uh, I have validation data is in I have validation data so x y x underscore test tst test y underscore test fitting the model. You can see the accuracy. We are starting from 95 training accuracy and validation accuracy of 97, listening. We are going down, 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 and our model loss is. You can see the loss is decreasing. I think loss should decrease, and so it has decreased to 10. Our accuracy is going high. Our accuracy is going high. Loss are decreasing, and we have getting the accuracy of 90. What's the difference between? I think we are getting a high accuracy on validation and both for training also, isn't it? So you can see the R model we are getting a accuracy of 95% and loss has decreased 11th 0 11 and our accuracy has 95% for training accuracy and 98 for validation accuracy. And just I have to just printing the keys of I have this key loss key validation key, model history dot history keys and history keys. So this is a model history and this is a model history keys and loss accuracy validation loss. I can use these keys and keys to use it for plotting and for any other cases in it. And for I'm just using these keys. I'm just summary the history of the accuracy. I'm just plotting using matplotlib dot plt and plt that model history dot history and I'm using the accuracy dot and I'm using the for history of accuracy of this model and I'm plotting it and I'm also plotting it to the model dot history of this models and using the history feature and then I'm just doing for validation I'm just doing using the history instance and just I'm just doing validation accuracy, and this is the model accuracy, and this is the accuracy. Title, I've given title and accuracy. For this is for accuracy, and this is for epochs, and this part I have just trained for. I have given legends, train and test in the upper left, and I'm just showing it. Oh, you can see there our model has reached. I think I have significantly we are going training data and validation accuracy also. Validation accuracy I think it started from 97, so it is in about 96, I think 96 range. It's more accuracy and with epochs and so summarize for losses and I'm doing for model history of loss and model history validation loss and just I am giving title model loss and x means x level is epochs, y level is loss and I'm using also train and test and locating in upper left is an NPL just showing it as our model loss has decreases from here to here and model from loss from here to here. This is our model accuracy and model loss and and this is our testing part. What we're doing here is I am just applying the predict method is in the method to the x underscore test and and I'm storing the values predict value into y underscore pred and it will contain some numeric values in numeric values so for it contains the list of numeric value I think so rf in numeric value and it will just if y underscore pred is greater than is equal to 0.5 in 0.5 it will is in it will you just if y underscore is greater than is equal to 0.5 means it has got label at what it is considered as true and true and otherwise it is considered as false and false and so you can understand it if the value is getting from 0 point is more of sigmoid giving the value of 0.6 means it belongs to the so in next classes you can assume that it belongs to the next class if greater than equal to 0.5 it belongs to the zeroth class and not to the belong to the 1th class and 1th class 1th levels and levels so from 1 o'clock we are just doing this and you can show there this contents and we have converted into the binary values in binary value for confusion matrix plot and this is y plot this is a y plot and we are just doing for this type of this only data sets and this type only data points so So I'm printing the from Ascalon dot import confusion matrix, and I am just using the confusion matrix to I'm giving the value y underscore test and y prediction, which is the real values and predicted value by the model. And we can see that we have error of 18 is in 18th, and this is our good. We are getting a pretty good confusion matrix also. This means I think of this class and of this class I am getting the 18th to this class and to this class, and so and I am getting the I am just wrong predicting two values, two data points of this to this class and this to this class, and this is good, making 18th wrong prediction, and for this column we are missing two values, and so we're predicting as this so confusion matrix. I think we have get the pretty good confusion matrix also, and we have missed I think 18 and 20 missed 20. We have missed 20 data points. So I am just doing accuracy. I'm just calculating accuracy scores any from any accuracy score y underscore pred, and I'm just giving the y underscore pred and y underscore test is in y underscore test, and this is our score. We are getting 99 90% score is on testing data sets, and we have getting the confusion matrix. I think we have done right classified 908, we have classified right, and 18 right we have classified is in wrong for the class A is in for the class A, and for the class we have done 72 good classification, and two bad classification for the next class B, or you can see 0 or 1 classes in. And this is our model, and and this is it for the tutorial.